So in this video, we're going to do a couple of example problems when the object is launched from a height and it lands on the ground. Okay, and they can ask you like all kinds of questions here. You just have to understand for part of the trip, there is that symmetrical aspect. Let me highlight. So if you look at here, you got A to C, right? So there is this symmetrical piece. Where you just have to figure out, we may have to figure out the time from there. But understand that the vertical displacement is just simply from point A down to point D, where in actuality, if you're trying to find total time stuff, this part above the ground or above the launch point doesn't necessarily concern yourself. Again, that's if you have to find final times and so forth, okay? But if you have to find maximum heights, you can see here in this first question, then you're going to have to take that part into consideration. All right. But again, we just follow our steps. I can't stress how much these steps are important. Okay. So step one, break up that vector. So VOX and VOY. So VOX. So this tells us we're throwing an object from the top of a 100-meter tall building with 50 meters per second directed at 37 degrees above the x-axis. Find the max height relative to the ground. Okay, so we're going to have to add in that extra 100 somewhere. The time to reach its maximum height, and then the total range. Okay, again, range meaning horizontal displacement. So we got VOX equals VO cosine theta, VOY equals VO sine theta. All right, again, this will be 40 meters per second, and this will be 30 meters per second. You should recognize that this is a 3, 4, 5 triangle. Okay, this is what tips it off at 37 degrees. All right, so now we can break it up into our H and our V's, right? Our H, our horizontal side, and our vertical side. Now we write the functions for position. This is easy, it's just 40t. Right, we're just going to take our initial x velocity and multiply by our time. Our y, okay. Now I'm going to expand it. All right, and then we'll talk about this y0 part here in a second. So we're going to go 30t minus 5t squared. Okay. So you could do a couple things here with this y and y0, but the main thing is, remember, y minus y0 is delta y, right? That's our displacement. So what I can do is just say, all right, let me just bring that over to, let me subtract that y0 over and write it as a displacement function, not necessarily a position function, all right? So maximum height, time to reach its maximum height, that goes back to our symmetrical piece. So what we're going to do here is we know that we have a displacement of negative 100, right? Because we're going to land below our starting point, which means now I would probably need to use quadratic equation to determine the time to get to the maximum, or actually this would give us our total time, sorry, by using the quadratic equation. But remember, the symmetrical piece, we can actually just use this and say, okay, that is going to be, A to C in that picture before, where I can find the vertex of that, right? So negative B over 2A. And so that would be negative 30 over negative 2 times negative 5, right? Again, I switched to 5. I know in the other videos I was using 4.9. So this would be 3 seconds to get to the maximum height, okay? And then we can just plug it back into our position function to figure out what is that maximum height, all right? So the function I'm going to really use is I'm going to use this 100 plus 30, so I'm going to substitute y for 0. Okay, and so I'm going to plug in the 3. What happens is when I plug in that 100 for y0, it just says, okay, now I'm starting 100 meters off the ground. Okay, so there's my, here comes my maximum height. So we got y equals 100 plus 30 times 3 minus 5 times 3 squared. Okay, and so I get a maximum height of 145 meters. Sorry about the extra hump on the M. Okay, so there's my maximum height. Here's the time to the maximum height. Okay, now I'm going to give myself a little room here, okay, to figure out, to show the quadratic equation. So for the total range, what I need to do is I need to determine the total time. And so that's what I'm going to use, that 100, 0 equals 100 plus 30t minus 5t squared. Okay. And again, basically I'm just finding the root. So t equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. That's our quadratic equation. We're going to do negative 30 plus or minus the square root of 30 squared minus 4 times negative 5 times 100 divided by 2 times negative 5. Okay. So remember my statement, physics writes math backwards. So you do have to be careful when you do your quadratic equation, because the math is highest order to constant, where physics is constant to highest order. So we're going to get 2 answers. We're going to, first one is negative 2.385. Okay, and then the second one is 8.385 seconds. Now, because we're in physics, we disregard that, the negative 2.35, right? Because time can never be negative. And so it takes, our total time would be 8.385 seconds. So I'm going to take that and plug it into my x position formula. And now this will give me the range. So 335.4 meters. Okay, so that is the range. All right. So let's do another example. Okay. Really asking, again, just a different type or different question. Okay, so we have a rock thrown from a 60-meter high cliff. And sometimes maybe if you need to, draw the picture, right? And so it's going to go up and then down, right? So our height is 60 meters. And what you can do a couple things. You can call y 0 down here, which makes y equal to the positive 60. Or you can switch these, okay, if you want to do that. All right, so we're throwing it from a 60-meter high cliff, 50 meters per second at 53 degrees above the x-axis. Okay, find the vertical component of the velocity at the ground, and then the total time of flight. Okay, so again, follow our steps. VOX equals VO, excuse me, cosine theta, VOY equals VO sine theta. Okay, and remember, and so this will be 50 cosine 53. And then 50 sine 53. And what happens is the other angle of a 3-4-5 triangle is 53 degrees. So what really happens is the switch. So above it was 40 and 30. Here it's going to be 30 and 40. Okay. Write our functions. And so x equals 30t, y equals, and we'll write the whole function, so 60. So we'll say that our initial velocity, our initial position is 60 meters, okay? And then, so 60 plus 40t minus 5t squared. Okay, and so if we want to find the total time of flight, so let's answer part B first. Now, again, we're going to use that quadratic equation. So here we're going to say t equals negative b plus or minus b squared minus 4 times a times c. Always do that. Always get it too close to the scroll bar. So let me erase this out. Okay, and then we'll do it again. So it's going to be a mixture right here. So t equals negative b plus or minus the square root of, let's just plug in our values. We know what the quadratic equation is. I just wrote it up above there. So it's going to be negative b, negative 40 plus or minus 40 squared minus 4 times negative 5 times 60. All that over 2 times negative 5. Okay. Again, you're going to get two answers. One's going to be positive, one's going to be negative, which is expected. So negative 40 plus or minus. So we got one time is 9.292 seconds. That will probably be our positive answer. So we get 4 minus 2 root 7. And so our negative answer would be negative 1.292 seconds. Again, disregard that point. And so here's our total time of flight, our answer to part B. Okay, we don't have to worry about the horizontal because they're not asking us for the range, but to find the y component of the velocity at the bottom, we're just going to do v0y minus 10t. Okay, so vy equals 40 minus 10 times 9.292. So vy, it's going to be probably roughly 50, somewhere in there. 40 minus 10 times 9.292. And so it's going to be negative 53 meters per second. Okay, so that's our answer to part A. Okay, in the next video, we're going to look at what happens if we kind of do the reverse, if we go from the ground up to a height, and then we still have negative launch angles to do.